Tall, thin, wiggly, a little bit of warping, wet filament except when it's not, a massive blob of doom, all this and more, Print Fix Friday, episode 24. Let's jump into it. Hey, welcome back to Print Fix Friday. If you're new here, make sure you leave a like and get subscribed. We've got a lot of awesome fails and fixes for them, so let's go through the entire table of contents for this episode. We're going to start off with some tall, thin, wiggly parts and how we kind of deal with that problem. Next, we move into a fail that's not really a fail, but has some failure properties to it. We're using some rubber bands to combat warping, but we've definitely got some other issues in the print that need to be dealt with. After that, we move into our own failure where we actually, seriously, I kid you not, had wet filament, and we can show you exactly what it looks like. Then move into a crazy roller coaster ride from my buddy Ivan Miranda, who just took an entire live tweet series of a roller coaster that I was not expecting, but really enjoyed the ride. And we finally end off with a nozzle to heat break issue from Facebook. Don't forget to use the hashtag PrintFixFriday if you guys want to get your fails featured in these episodes. You can tag us on all the social medias. That's probably the best way for me to see it anyways. But enough of me yabbering. Let's get me into yabbering talking about the fails. Take it away, Grant. Thought I fixed my printing issues. Guess not. I'm gonna go with it's not really your fault. We got some issues here. I mean, Stevie Wonder could tell you this ain't right. Mind you, feel it, but anyways, bad joke. I agree with this top comment. Tall, skinny objects plus gantry mass equals problems. Cartesian printers are not designed to print tall, skinny objects. Go get a wooden dowel. Go get a steel rod. Go get a piece of tubing. Why? There's no reason to 3D print this. Like, I get if you're trying to tune in a system, but there are so many other issues that can come involved here, right? Your contact to your build plate is minimal at best. And even if you put a brim on it, because remember, if you like it, then you should put a brim on it, you're still not going to have enough bed adhesion. Because a brim is only one layer thick. And sure, you could go in and edit it to make it larger and all of that. But at what point are you just making the entire rod larger to get more contact to the build plate? This is one of those cases of you're trying to solve a problem that basically every printer has. Don't worry about it. I understand that can be frustrating for some, and that's totally fair, right? I am not going to discount this whatsoever. It definitely sucks. However, there's not an easy way to fix this for a Cartesian printer. Easy way to fix it is not to use a Cartesian printer and to use more of a Core XY style, maybe even like a Voron 2.4. By the way, do you want us to build a Voron? Let us know down in those comments. I've been talking with some people in the community, and maybe it seems like it could be potentially the right time to build a Voron again. I don't know. But yeah, this is... I'm not going to really call this a fail. I think this is more of someone having issues with the understanding of how the system works rather than print issues alone. We do have a Z-seam. We have a pretty obvious Z-seam here. That's going to be retraction. We've got some squishing, some color issues. That's going to be cooling, right? These are really tiny parts. If you don't give them enough time to cool off, you're going to have a bad time. Stop it. This is one of those cases of this is not a good thing to 3D print in this type of technology, or at least minimally with that type of 3D printer. Look at getting one where the bed does not move back and forth, it only moves up and down, and I think you'll have a much better time. And I understand that Grant is telling you to go spend hundreds, if not thousands of dollars on a new printer, but if for some reason you want to make rods like this, that's kind of going to be your option. You could look at cutting them down the middle, printing them flat, gluing them together, but who the hell wants to go through all of that work? Not I. Yeah, I would look at running a temp tower minimum. It looks like you got some heating issues, but that could just be because of your cooling issues. We got retraction issues for sure, go ahead and look at tuning in those retraction settings. It's tough to tell. I can't easily tell which direction the printer is moving, so I don't know if it's retracting too much or on the de-retract if it's not pushing enough filament back. But if this is something like a Bowden printer, make sure that the de-retract is quite a bit slower than the retract. That way you don't end up with some back pressure issues. I'm bummed that there's not really a good fix for this other than you're just not using it correctly. And I don't like saying that often. You all won't really ever hear me say that often because I kind of find it a bit rude, but I don't really think there's a better option here. If you got a better option to fix this problem that does not involve them with a new printer or cutting the part in half, let me know down in those comments. I'd love to know what you guys think. I will not allow my 24-hour print to be warped. I will bend it back and straight. This is probably the most ingenious way I have ever seen someone deal with warping. And while I'm going to give credit where it's due, that is certainly interesting. Good Lord have mercy, we've got a lot of other things to talk about here. First off, retraction is a problem. Oh my gosh. All right. So we've got some issues here. We've got a lot of random blobbing and stringing, and we've got areas where it's not printing correctly. I'm gonna say this is a retraction issue, but there could be some part of the geometry that's not printing well, causing it to blob up as well. We're seeing some sort of deposition as it's moving. This is over here is deposition from when it's retracting and moving and there's still crap on the hot end, or the hot end is leaking during that movement. You gotta solve that problem. Look at increasing retraction, but you've got this issue here too, which is where it's not extruding the filament right after the retraction. I'm curious to know if your extruder hobbed gear is loose. I think it might be loose. We're having issues with blobbing, but we're also having issues with extrusions. That tells me maybe there's some backlash issue on the extruder gear itself. We're seeing some sort of ringing here and artifacting. This might be Z-wobble. But, like, dude, I'm gonna give you credit in that this is the most ingenious thing that I've ever seen. Also, what the hell? That's an orbiter. Wait a minute. This printer's, like, decked out. PETG, adhesion issues. Get the bed right. You put so much effort into your hot end. That's a freaking orbiter. Oh, my God. For the last fucking time. It's not wet filament. This is wet filament. We're going to get to that in just a minute. Stay tuned if you want to see what actual wet filament looks like. People of the 3D printing community, 99.9999799 times out of 100. It's not fucking wet filament. Stop it. Yes, PETG is hygroscopic. We know this. It absorbs water. We know this. And this part with wet filament was actually not open very long. The spool was probably not properly vacuum sealed from the factory. We're going to get into that in a bit. But it's not wet filament. It's not. Stop it. Get that shit out of here. Seriously. I hate when people say this. This is not wet filament. It's not. Yes, on PETG, wet filament can cause stringing. It's hair stringing. It looks like this. You see these hairs? That's what wet filament is indicative of on PETG, and PETG is stringy as it is. Stop it. It's not wet filament. It's really upsetting because this person has obviously put a bunch of work into making this printer work. They've got like $150 into their hot end easily. The orbiter's something like 60 bucks on its own. Links in the description, I guess. I do like there's some commiseration occurring in the comments. If you think that's bad, try partial nozzle clog 36 hours into a 40-hour print while you're asleep. I feel you. You see it? I feel you. But this is actually kind of cool. It actually worked. So kudos to you, OP. Yeah, if you crank the bed temp up and let the material soften and use a set of rubber bands, I guess that works. I mean, it's jank as hell, but I guess it works. Oh my God, people. I've been on a mission that white filament is truly the worst color that you could ever print in. Do I need to go on a war mission along with Pooch of Repcord and Andrew Mayhall from Gloop, by the way? future podcast guest. Get subscribed if you want to hear all about 3D gloop and how amazing it is. But if I have to go on a warpath to show you guys wet filament really doesn't matter all that much, I'll do it. I live in Florida. I can leave things outside where it is currently like 80% ambient humidity, and it is 10:30 at night. It is just below 70 degrees. Nice. It's balmy out there. Yes, an enclosure would really help this situation. An enclosure would absolutely help the situation. If you are dealing with warping on PETG, an enclosure will help. This appears to be Creality glass, where we've definitely had, maybe there's glue on here and something's being pulled up. Clean your damn bed. And honestly, you spent a bunch of money on an orbiter, and this appears to be like, I don't know what this is. We got a BL touchback there. I mean, we've got definitely an upgraded printer. You've put all this money over here, and you've put nothing down here. Put a little bit down there. Get a good PEI flex plate. Maybe something from Wham Bam. Code Musketeers for 10% off of your entire order at Wham Bam Systems. Links down below through the end of May of 22. But you know, I'll give you credit where it's due. People of Reddit, it's not wet filament. Get your head out of your ass. Stop it. You want to see wet filament? Let's talk about wet filament. I've got wet filament. This is actually what wet filament looks like. Let's take a look. Do you see the little Rice Krispie pops? And then all of a sudden it goes away, and it definitely failed to feed for a bit there, and the printer stopped, and everything had to stay inside of a hot box for a while, then the filament dried out. Yeah, guys, this is actually what wet filament looks like. Now, here's the deal. This is gunmetal gray PETG from Printed Solid. This was a roll that had been open for about 4 days, and there is no way it absorbed this much water. So most likely the vacuum seal had broken at some point. We've had those spools for a few months, and even then, I don't know. This roll was pretty wet. But we left it in our filament dryer, and you can see about 5 hours later, when I finally fixed that extrusion issue, the printer had paused and waited for me. That the rest of the print looked pretty good, except for a little bit of stringing here, the little hair strings. But there's more to this failure than meets the eye. Take a look at this edge, ladies and gentlemen. You see that random weird extrusion pattern? And how it ends up going on to the actual part itself. I got to give a shout out to my buddy Ben once again of Tiffy's Lemonade Stand. Ben helped me solve this problem to the effect that I have more of them. These are client parts. I'm trying to print like stupid fast. This entire part takes 12 hours. It's 390 millimeters long. It's a big boy, and it takes about 12 hours. Lo and behold, inside of Prusa Slicer, if you have your max speed set well above what your print speed is, that's going to cause problems for your printer, especially printers with really long Bowden tubes. The printer that we are using has a 1 meter Bowden tube. Seriously, one whole ass meter. It is stupid how big this Bowden tube is. I really want to convert this printer to direct drive. Maybe that'll be a video in the future, although honestly, it might be time just to sell the printer. We'll see. With Bowden tubes that long, you run into issues of the printer trying to print faster than it should. And that's exactly what's occurring here. So not only do we have wet filament, we forcefully let it dry for 5 or 6 extra hours, and we had a print that looks considerably better. This is literally the same spool with Ben's settings, and you see absolutely beautiful. The exterior looks good. We still have some banding right there. There's really not a good way to get rid of that, unfortunately, especially for really long Bowden printers. And I am still tuning in this particular file, so this one is not perfect, but these two are the exact same spool. Yes, it's the same color. We're doing a lot of these in the same color. Those two are the exact same spool. I have them marked that way, so we could use them in this video. But yeah, this is actually what wet filament looks like, seriously. The Rice Krispies there, the little pops and crackles, what looks to be shiny filament is not shiny filament. It is wet filament. So, Ben, thanks, dude. I appreciate your help, and you know, hey, if you guys want to get some really cool 3D printed and laser cut goodies, go head over to Tiffy's Lemonade Stand. Links will be in that description down below. But yeah, this is what wet filament looks like right here. And then when you dry it, it looks like that. If it doesn't look like that, it's not wet filament. Stop it. Why does everyone have such a I don't get it. And I want to change it. Just like I want to change my segue to our sponsor, 3D Musketeers. If you want to get your ideas made in real life on awesome 3D printers, you can reach out to the pros at 3D Musketeers. They have almost 3 dozen 3D printers to help you get those ideas out of your head and into your hands, 100% art to part. And if you want to learn more about what we do, I was just on an interview with the one and only Lisa Lloyd, a Shark Tank shown inventor, where she actually made a deal with Barbara Corcoran and Damon John, whose birthday actually happens to be today, so happy birthday, Damon. She's amazing. She's an absolute amazing person who does wonderful things in the product development industry, and she just got her first 3D printer. We were talking all about 3D printing and product development, and if you want to ask her questions live, get subscribed, because in 2 weeks, March 12th, Lisa is going to be on our podcast hanging out. So yeah, the pros at 3D Musketeers, we got those connections. We had Chun Ung, we got Lisa Lloyd. I'm working on Josh Malone, and if you don't know who that is, look him up. Zuru Bunches of Balloons, a lot of great inventors coming here on the channel. And if you want to support these efforts, because it is a little difficult sometimes to get a hold of people, you can do so over at Patreon. They kick a couple of bucks into the can every month, help us make the awesome content that we do, or you can join YouTube channel member, listed right below me with the join button thing. We greatly appreciate any way that you guys can help us out outside of just watching the videos, liking, subscribing, and sharing it with others. Anyways, let's get back to fixing some fails. We got Ivan Miranda on Twitter, and I saw this and said, oh, shit. This is truly one of those fails where you're like, oh man, I need to see more of this. Look at that monster. Like, I'm expecting a face hugger to be launching out at me. This is one of the most interesting blobs of doom that I have ever seen. Not only is it all around the hot end, it is all around the hot end. You dig? So I commented on this before I realized there's a saga here. So let's look at this saga. So we made a big mistake in the slicer, not sure what happened. It definitely looks like your temps were not high enough. This is common when you're trying to print really fast and your temp is not high enough to deal with that temperature. We can see, yeah, a pretty serious layer shift. Wow! It shifted God, that's gotta be 2 inches. That's a big friggin' layer shift. And just look at that boy! That's a thick boy. That's thick with like 8 C's. Good Lord have mercy. That thing is nuts. We have a screw that fell out. Not all are bad news. Big disaster averted. The part cooling fan is out and alive. Hot end cooling fan saved. If this one failed early on, most probably heat creep would have saved the rear fan. It's true. It's true. Man, I got a Bondtech on there too. Is that a reverse Bowden? It is a reverse Bowden. Beautiful. BL touch is good. This is where running out of filament saves you. He got lucky. Running out of filament was probably one of the few things that made this fail a whole lot easier. And desperate times call for desperate measures. Leave a like if you've ever had to do this, because I know I have. We actually had a client years ago that tried to clear a clog with a blowtorch and melted their entire hot end. And I guess I can see somewhat of a logic behind it, but please don't do that. Ivan knows right here that everything he's hitting with this heat gun is trash. It's gone. But we can see... Oh, yeah. The gloop. The gloop. We can see the heater block. This is what we tell people. We tell people if you do have a blob of doom like this, basically... the entire hot end is generally going to be a write-off. This is I can tell it's a mosquito of some sort. It might be a mosquito magnum, but minimally you're gonna generally have to replace your thermistor and heater cartridges. Are there 2 heaters? There are definitely 2 heaters going to that hot end. Dope. We've got the entire thing open. Good Lord. That thing is ugly. Let's clean this bad boy. It's still running. You know, I'm going to give some credit to Slice. I'm friends with Dan. And while their hot ends are expensive, there's not a single person that's going to say, oh, Slice Engineering hot ends are cheap. They're not cheap. They're not trying to be cheap. They make good quality hot ends at a good price if you want something made in America. These are really good hot ends, and this is a testament to it. Oh man, even cleaned the whole thing off? Come on. This honestly looks close to what it would look like factory, minus the little bit of red. But hey, we all know red is the fastest color. I'd leave a little bit of red on there, you know, make it print faster. I like it, clean enough. Everything's looking good. Ivan is doing a phenomenal job here, and it poops! It works. I can't believe that this thing still works. Blows my mind. Like, there's a lot going on here. For those that haven't picked it up, that is a gear reduction system for a stepper motor. They're clearly running an ass load of filament through this thing, and likely needing an ass load of cooling. When you're using a 50-15 blower fan to cool the cold end of your hot end, yeah, you're doing some stuff, and those lines are big too. This is one of those downsides of having a printer with a big nozzle putting down fat layer lines. When you have fails, they tend to really suck. And we can see here we've got the graveyard of tools that were used. It's a big printer. It's like a G-Max of some sort. Look at that. Is that triple Y? It's gonna be quad. I think it's a quad Y. Boy, howdy, that's a printer. I want to learn more about this. Replacement parts printed. 221 grams of fail. Ivan, don't throw this away. If you don't put it on display, assuming you're in the United States, I will pay to have this shipped to me. I want this on display as part of, like, we want to put on a display of fails. I would love to have this on display. That's ridiculous. And this is the great thing about 3D printing. You can just print all the broken parts, self-replicating. It's so cool. I'm really glad that he got this thing running once again. This is really, really great to see. The printer looks like it's in great shape. The lines are looking pretty. Ivan knows what he's doing, right? He knows a thing or two about stuff and things. So this was very much a roller coaster for me. I hope that you all enjoyed that as well. And apparently, I gotta give this guy a follow. What a great freaking fail. How do you solve this? Dude, we don't even know how the hell this started. It's likely from that layer shift. It got all around. That's one's gonna be don't leave your printers unattended. We know you're gonna do it. I'm just gonna tell you not to, and when you do it and you have a fail, I'm gonna tell you I told you so. We've got a user here from Facebook. I know, the place where everyone goes for good help. But this one actually had some good help in the comments. Let's take a look at what's going on. So I've tried around 10 times to tighten my nozzle and still no progress. Don't know why, but I can't secure it. Have reassembled the whole hot end twice. This is the same for 2 of my other printers. Why? I followed all the tutorials and even contacted Prusa support, and they can't answer. Let's take a look and see what's going on. We got some wiggle, wiggle, wiggle. And so what's going on? Your nozzle is not tight against your heat break. How do you solve this? Well, you've installed a new nozzle. It appears to be a hardened steel nozzle. 1, put a freaking heater sock on your printer. It will keep things a lot safer. 2, that is not a stock thermistor. Interesting. I haven't seen thermistors that look like that. Normally they've got the blue or pure white wires, never ones that are black and white. It doesn't really matter at the end of the day. You don't have your nozzle tight up against your heat break. So what do you do here? Well, you gotta tighten the heat block further onto the heat break, or you gotta tighten the nozzle further onto the printer. You also need to do this hot. Since you're touching it, I'm gonna go ahead and assume that it's not hot. If it is hot and you're touching it, maybe you worked in a kitchen before. I'm not here to judge, but everybody in the comments is saying the same thing. Heat break is not tightened to the heat sink. This can happen when tightening the nozzle. This guy says should print fine. No, don't listen to that. If your hot end is wiggling this much, we've got a problem that will likely result in your filament coming out of the threads themselves and oozing all over your hot end, creating a massive mess. It's fixable, of course, but the fix is to take all that burned and melted plastic off, and then hot tighten your nozzle to your heat break. We've got ourselves a heat sink, heat break already installed. We've got ourselves a heater block and a hardened steel nozzle. When you're assembling everything, what we like to do, and this is pretty much per E3D guidelines, you screw in the nozzle all the way. You back it out about 2 turns. Okay? Then you go ahead and put your heat break on and you cold tighten. Okay? Everything is assembled just the way it is, and you can see there's no wiggle. The only wiggle is from the squishiness of my fingers. Then, when the printer is up to temperature, and when I say up to temperature, this is a Prusa, 285. Cook that bad girl. You get a socket wrench that fits the nozzle. You grab the heat block with a pair of pliers. Do not grab it with your hands. It will give you instant burns. Don't do that. Grab it with a pair of pliers. Be careful not to short out either your thermistor or your heater cartridge. And then you hot tighten everything together. Once you do that, you're not going to have this problem. And you can see, this is cold tightened, of course. It'll need to be maybe another half turn. But we've got some stick out of the nozzle, some difference between the heat break and the heat sink. So we've got ourselves basically a ready to go hot end. That's what needs to be done here. You can do this all while it's inside of a Prusa. You probably shouldn't. I've done it plenty of times, but you probably shouldn't. So that's all you got to do. Make sure that nozzle is tight against the heat break. If for some reason you're running into a wall that's not metal, go ahead and heat it up and then do that final tighten when it's hot. You can do this entire process while it's hot. We tend to. I don't really like to do cold assembly, then hot assembly. We just go ahead and do straight hot assembly. But you have to kind of be comfortable with handling all of this because it gets very hot. 285C is the definition of holy shit hot, but it works. And yes, for those wondering, this is not a real heat sink. Okay, I'm sorry. It's my heat sink that I use for demonstrative purposes because it's a weird gold color. But yeah, that's how you solve the problem. Then you'll be back up and printing with a good running hot end. Everything will be absolutely copacetic from there. Let me know what you guys think of these fails and my fixes. I'm not 100% sure that I got the first one right. The one with the tall towers. I understand that the easy solution is just reprint it on a different style printer, but I don't know if that's all that fair. I'd love to know if you guys have other advice you might be able to give for that one specifically. But the others, I think I got them down pretty well. And again, I want to give a big shout out to my buddy Ben. Thank you for all the help getting this big Bowden printer dialed in, running a lot nicer. And actually, if you hear weird things in the background, that's the big Bowden printer. It's a little noisy. Anyways, guys, make sure you get subscribed, leave a like. That's all I got for you on this episode of Print Friday. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. I got tall, skinnily... Blech. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our patron supporters and YouTube channel members whose names are listed right next to me at the $5 tier and higher. If you want to join this elite group of Musketeers, get access to our super secret Discord, and many other channel perks, you can do so by joining Patreon or YouTube channel members. Links will be down below. Speaking of right below me is the entire PrintFixFriday series. So if you're looking for something else to watch, go over there, take a look. I think you guys will enjoy it. Right next to that is going to be the entire printer maintenance series, with next week we're going to be doing a resin printer maintenance series. We just covered FEP. Go watch that one. I think you'll enjoy it. We'll see you down in those comments and the next one. Take care.